Good afternoon, everyone. How are you? I think they are under mute, no? Right? Hello, Vignesh sir.
Yes, sir, we're on mute, but we are audible.
Fine, fine, fine. Right. Thank you very much, Vignesh sir and uh, J- Jay Kumar sir, for giving me an opportunity. And myself, Kannan, working as a field application engineer in exhibit electronics. And I have contact with your institution almost half a decade. I mean, more than half a decade, around 8 years. So we were doing training programs these many days, and we have started our office with a motto to bring awareness among students community particularly, and the main intention, the purpose of our office is make the student to understand what is our career in electronics. Of course, everyone we do 4 years course, and later we are working in an environment maybe related with electronics or not. So it's not a thing about to discuss here. And my point is like particularly the people who were learning electronics, they should know why we have learned, for what reason we have spent these 4 years among behind the protons and neutrons and electrons and neutrons. So this is our intention, and we are here. Maybe this could be the right time at the grade. I mean, first year, we have got an opportunity to interact with yourself. The meaning of how and where we have to start our area, so that we can see our future. I mean, we can project ourselves how in the society related with the electronics. Sir, can you hear me? Vignesh sir?
Yes, sir.
Right, right. Thank you very much. Let's go to the session. Electronics, an application based approach. So this term electronics, it's a well known to you. Well known to you. You have been studying last 1 year, and today we are going to see about the same thing, electronics, but in some other way. Like, what are the applications of electronics? Where you are using this electronics? What is mean by end prototypes? What we can do with electronics and how we can learn with electronics. So where we can start with electronics. So most of the people, when I see after my engineering this 13 years, uh, all the most of the people, like they do not know where to start and how to proceed. So this session, this 1 hour session, sure will bring you where to start and how to start. Will give the knowledge to you. Let me start with the slide. Right. It's a common question. Where do you find electronics? So electronics is found everywhere. That's a common answer from you guys. But intentionally, when you think of any application, you would have studied basic diodes or thyristors or some other else. And when you think of electronics, the electronics gadget doesn't end with what is it, resistor or capacitor. It has much more component. It has much more technology. It has much more hardware, which has much more software, IT related with everything. It comes related with the electronics. So the best answer is from a kid till a giant, from from the toys till the satellite communication, we have electronics. And next, yeah, today what we are going to learn, we're going to learn the electronics and sensors that is related with our day-to-day activities in real life applications. And then we're going to discuss about the circuits, how we are going to design the circuits, from where we have to how we have to analyze, and from where we have to start. And final thing is, like, one more session I have added here, PCB prototyping, where how to develop the PCBs using the software. So electronic doesn't ends up with the hardware. It works combinedly with software, and the end product, it is the joining of hardware as well as the software in a pure embedded system, a pure electronics, right? So when I split up the application, I have divided domestic, industrial category, again in industrial, medical, environmental application, agriculture, and the satellite, high microwave applications, high gigahertz, high frequency applications. Excuse me, sir, Vignesh. Excuse me, sir, Vignesh. Hello, hello.
Yes, sir.
Right. Can you hear me, sir? Please, can you reply? Can you hear me?
Sir, we can hear you, but Vigneshwaran sir is muted.
Fine, fine. Thank you very much. So the application we have divided like domestic, and now we're going to see about it is a known topic actually. It is a known topic, electronics application areas. So wherever the you have the PCB boards, wherever you have the resistor capacitor. I mean, due to the issues in my PC, I just went to a internet center, and from there I'm sharing. If there any noise, kindly ignore. Uh, and I sincerely regret for this thing happened this in this session. Right. Though this topic electronics applications. So from the time when you get up, wake up from bed, probably 3:30 or 3 o'clock, until the end, probably 12 o'clock or 11 o'clock. So wherever you see the gadgets, or wherever see the thing that is sure, wherever the product you feel, wherever the product you touch with the power supply, you have the electronic. That's a simple concept or simple thing behind the application areas. And in this domestic, what we are going to see now is the gadgets that we use in our home. Simply, we can say home appliances. This refrigerator or dishwasher, washing machine, and microwave oven, and so many other like audio systems, vacuum cleaners, like so iron box. These are the fixed applications. But the student community, like you know basic things, like these are related with electronics. But my purpose, please everyone listen, my purpose application areas is how we can make some modification with the systems. For example, when you see the iron box here, it is usually plugged in and the device will be on. The smart thing, my approach, like my approach among the application area when related with iron boxes, when you left the place with switch, when the switch is on and you left the place, sure it will be in on only. It will make you the additional advantage, additional EB cost also. And the smart way we can make it is like when you place it vertically and with a particular span of time, it should get switched off. So that is the smart way of make changing our application. And this title, it not only describes about I mean the content, the agenda, what I'm going to discuss is not only about the application. Everyone know ironbox will do ironing process, but the smart way how I can modify these things, either it's a kettle or uh, iron box, or with my smart plug, with my smart camera, the things I can embed with my mobile phone. So these are the application areas. And now I'm going to take you into a sensor area, like how the data can be gathered from our entire world, and how I can make it control. I mean, make it control it and display it. So the smart way of modifying the existing applications, that is my approach here, and that's my agenda here. I will discuss with you now. uh, industrial electronics, each and every machinery equipments, like for example, uh, if you consider a mobile phone manufacturing industry, you have various machineries. For example, you have the SMT line, surface mount technology. But better you can have some paper or notebooks so that you can write the important keywords which you are hearing. Uh, very first. So there is a concept called SMT, surface mount technology. We have around five shop floors. Like one is for making PCBs and getting the PCB and assembling with the components. That is SMT, surface mount technology, only with the active or passive components, which is a raw material for the mobile phone. And then we will place some holders like SIM card holders or SD card holders, or some sockets or power connectors. So those are the mechanical things, and we will be placing it and adding some Wi-Fi shield. So those are the flow. Like here, again, in these machinery equipment shop floors, we use electronics. Particularly when it's a pick and place operation, there will be have some sensors. Like when you place it, the robotic arm will come, and then it will process the particular PCB. After finishing it out, it sends to the PCB, and I have a display. I have finished this task. The task one completed. So number of production lines, how many PCBs I have, how many, either not only in mobile phone manufacturing industry, in every industry, these machinery, they are very smart, and they will do the job as well as they will give you the displays. Like it will give you the information how much it has processed, and it will find out. We can easily find out what is end of the results in the finishing of our regular shift. So machinery, equipment, shop floor, warehouse, vehicles, and electronics is found everywhere in vehicles. Not only vehicle, in tracking our vehicle. After the finishing goods, we can check, we can track with the electronics. So these are the small applications, and I will give you in detail when I proceed further. Just observe the slides, first 4 to 5 slides, then we can see in detail. So when I say electronics and its application, of course, application in the sense getting the data from the environment, like the data we have to process. Sure, you're going to get it for processing. Those data are observed by the a special part called sensor. It will sense the exact criteria, or it will sense the exact information and will give the system. A basic application is like even now I'm utilizing it. It's a microphone, and from here, the stage by stage, when you see the observation slide, you will get to know what is a sensor, or how I can able to create a own application for myself. The purpose of education is to make yourself to create your own. You can read many books, you can read many websites, and finally the purpose of this session is how you have how initiates your thinking capability, and so on. It's not like seeing the slides and saying by, right. So these terms, I think everyone knows, like microphone, amplifier, loudspeaker, amplifier, the common term CB amplifier, CC amplifier, CE amplifier, and most of the amplifiers, right? Electronics and sensors, because the system will work very fine only with the data gathering and processing and displaying. There is a product. That is a product, electronic product. And particularly I focus on a part, because sensing, processing, displaying. So application areas I will discuss, and in addition with this, I just want to know you, get you know the information, like the sensors, and how we can able to design our system. Like, yeah. So here you key a you are seeing a number of sensor. Guys, please take a note of it. These sensors and the application, just have that keyword and a simple explanation like what is this. Here we have few of sensors like ultrasonic and gas sensor, passive infrared sensor that's detect the human body temperature, humidity, and sound microphone, laser, flame sensor, photosensitive vibration sensors. Everyone have the you can feel the vibration sensor in a mobile phone. It's a simple small device, maybe hardly around 1 centimeter. uh, so it will give you the vibrations. You would have feel it. Tilt sensor, a common thing is like the process of water, in a water purifier it will gives a control when it's full, then it will disable your functioning, it will disable your motor. So it's a tilt sensor. And then what is raindrop, in the recent cars, we can see last 3 to 4 years automatic wiping sensor, that can be achieved with the raindrop sensor. And in agriculture we have a lot of application with the soil sensor. Again in ultrasonic, it's a non-contact uh, distance measuring sensor, ultrasonic with the high frequency waves. There are many sensors I will teach you, like a passive infrared sensor, which detects the presence of human body. It worked with the temperature, the changes in the temperature. It will radiate energy and it will receive the signal. So these temperature changes, it will give the output. Smoke sensor, almost the thing is, it's a physical part. It has a system. It just converts into electrical signals. So the data come, we call it as transducer. Maybe you could hear in future transducer. So these all are mechanical part. The conversion of energy from one form to another is a transducer. So this gas sensor, it converts into electrical pulses. We are getting the gas, the smoke. Either it's an ethanol or methanol, or this LPG, liquefied petroleum gas. It will detect and it will send into electrical pulses. Many sensors are there. We will see the applications of this sensor. Sure, I will going to explain you. And these are again temperature barometer, sound sensor, hall effect sensor. It's a magnetic sensor. So it is work with all the sensor work with the unique applications, with a unique concept. Either it's an electromagnetic field, for example, when you consider proximity sensor, inductive proximity sensor, it works with the electromagnetic field changes. And when you see the passive infrared sensor, it works with the concept changes in the temperature. When you feel the electrosonic sensor, it will works with the delay in getting the signals, pulses, time period. And this one, IR sensor, infrared sensor, like it works with delay or missing of signals, infrared signals. Right. This is the basic sensors here, a rotary sensor encoder, and this is where we will get the information via from the bike, like what is the speed, or what is the rotation, number of rotations. So we can get the information from rotary encoder, as well as we can get the information from inductive proximity sensor. And overall, these are the sensors that is commonly used for a system. And you can think about any application related with this sensor. Either it's a temperature, it's a simple, it's a temperature sensor. You are doing the auto cutoff with the temperature and humidity and magnetic sensors, right?
Sir,
This is
sir,
special. Sir, yeah.
sir, sorry for interrupting. A few guys are waiting to join the meeting, sir. You need to give them permission to join.
Myself, sir.
I think
Vignesh
Vignesh
sir.
sir.
Vignesh sir. Hello, sir. Okay, ma. I
Hello.
will call to Vignesh sir and then I inform ma. No problem, ma. Sir, you carry on, sir. You carry on, sir.
Fine, sir. Thank you. So here in automotive sector, we have the dashboards. So, like we drive and we enjoy in driving the automobile, but a lot of electronics is it's engaged with electronics. Like the best example is when you enter into your seat, driver seat, and you can see a dashboard where you have signs of LEDs, a basic signs of what is this light symbol or seat belt, what you see here, seat belt light, and the value of oil, engine oil, so what is behind this, how it is achieved, how it is made. Very simple. I'm going to explain you. Just get the details, like and my intention is, guys, please just analyze yourself. A very sad thing, just I want to share here is, these 2 years, of course, I can understand everyone completely disturbed. Uh, when I go to my office and when I see the recently passed out students, uh, they forgot or they doesn't aware of why we have spent these 4 years electronics. So again, I'm telling you, I have seen entire most of the people who have joined in our office, uh, like like they they couldn't imagine themselves who they are, like how or why they have studied these 4 years in electronics. See, you have selected a very premium institution. I know because I have seen many institutions where where the lab can be done only with the demonstration classes only, complete lab. I have seen even myself in institution I have studied. There also only one electronic kit, and surroundingly we will be having 15 to 20 guys just seeing experiment and saying I have done and get it signed from my external. But you have placed in an institution where they will give more opportunities, and even from outside, from industries, they would have they wish to have tie up with your institution, and they wish to give tools, sponsor tools to your institution. And and you should utilize the opportunity, students. So you should be aware. That's our even the main vision of our system, our office, and is to make you to get very clear what I'm going to do after this day, or after this month, or after after reading this topic, or after reading this subject, what we are going to do. So you should ask a question, and you should get an answer, not that the second, maybe after some seconds, how to start, how to work, right? And these electronics application areas, we get a common title called smart city. So in Tamil Nadu governance, or in nearby Karnataka, so they planning to implement the project smart city. What is smart city? Sometimes I feel very difficult when I'm speaking myself for this 2 years, but unable to communicate with the students. Yeah, I can understand, because even myself, I have the problem here. I'm in internet shop, so here some guys are quarreling here, some information. So I need to check myself. So
Sir,
I
since
just
how
start,
long are you working for the
sir.
company, sir?
Yeah, sir.
Since how long are you working for this company, sir? I mean, Exhibit Electronics.
Pardon, sir. Pardon me again.
Sir, how since how long you been working for this under in this industry, sir?
Sir,
Electronics.
I have been around 7 years, sir.
Okay, thank you.
Fine. So here in smart systems, like the smart city is nothing but each and every platform you are seeing here, it will give you it will give some information. Either you gather the information and it will give the information when you walk. I mean, or just in your it will grasp the thing from your healthcare and it will display it, and it will send to your cloud, and it will give you the information of the health status. And again in street light, it gives the security related information. Again from automobile industry, I mean, it will give you the information related with the vehicles. So these application areas is not defined, like for example, students just listen. If you think about application area in a car, mobility car, just you have certain dashboards. I mean, certain signs here, like it will give the temperature, or it gives the those readings, speed, and it gives the health status of your engine or seat belt or indicator. Those are very simple. And there is a concept called connected cars. So this car will speak to the nearby, either before or after I'm running in this much speed. That's a privacy, but it will give the information I'm running in this much speed. I'm going to stop my vehicle very suddenly. And so this information that is shared with the cars, that is connected car. Those are the application areas. In the future application and the future world, we are going to have speaking cars. So that is related with the transport. And in industry, it's a smart industry where there are some systems like in the smart city project, like you will be having a display where it will show you the emission of CO2 gases, and the emission of I mean the noise pollution related with the industry. So that these application areas, a proper governance will take measure, like how much CO2 gases it's producing, or how much the non-admitted gases related with the industry, how much it is producing. So those information, they will be gathered by the governance, and they will take the needed actions. That is the concept behind the smart city project. And everything, even in our home, like future, we have a present in some area where smart utility meters for water, as well as for gas, I mean domestic gas, LPG, liquid. So even in some state, it has been more than 5 years. Like it will you not to message or response to the IVR system to get your LPG. So it is available everywhere, and it's like a prepaid system. So that's the thing available in your home. It's a smart home. Actually, smart home. When we think about, I'm saying you the application, and you have to design your system. Just telling the story is very very simple, guys. But making it reality, and it's very difficult. And my I mean the purpose of my speech, the purpose of this guest lecture is like, I'm going to show you the basic application areas and what are the system involved in this application area. And you have to design, or you have to make a step beyond this story, how to implementing it. The way you learn, like, it not by seeing the PPTs or slides, or reading with the magazines. It's about how you are doing it, how you are experimenting it from A to Z, right? So smart health. And very recently, we, in our COVID situation, we have faced very bad experience with the availability of bed and availability of oxygen cylinders, the level of oxygen. And we don't have any web dashboards, I mean signs, like the list of hospital available hospital. There they said like we are going to give some website and showing it, but in practical we couldn't get the information exactly. This smart health is with the related with the hospital. It will give you number of available beds, I mean the number of oxygen cylinders, and I mean you can decide it very easily and fix up the particular hospital getting after getting the information. You can reach it on time. It's very good actually. Smart people. So smart people is nothing but it's related with the patient health care actually, related with the health status only, and smart energy. So these are the application areas. Even you can get the information. You guys are doing some project like prepaid electricity meters, and it will give a message to your Android phone how much unit you have consumed, and so many application areas like but you have to the designing the system is very difficult task here, and that's what I said, where to start. That's a very important question, how to start. And I think we have a better slide like how and where. Let's see. Overall the electronics, it is spreaded everywhere, electronics spreaded everywhere. And very recently we are getting a particular keyword repeatedly everywhere. It's nothing but your internet of things. Internet of things. The internet, provision of internet to most of the things. It's not with the human beings, human to human. It's not like with the brothers and brothers, or not with the sisters. It is like uh, maybe a pencil. Even a pencil can give the information about your body temperature. If you think this application, your body, you are writing with a pencil, and the pencil will give the information of your body parameters, and the pencil will give the information of surveillance, the status of your I mean the privacy options, and for security options. So that is internet of things we are going to see. And overall when this particularly this slide will give the answer, electronics and its application areas. It's around the globe, sir, around the globe. Only thing is how we imagine ourselves to bring the electronics into our creations, right? Yes, that's what we are speaking about in smart city project, water and gas metering. Sir, I will share with you like guys, the best way of learning. And you have done the task with the voltage, getting the data. When we consider a transistor, input characteristics, output characteristics, having the fixed IB and changing, I mean, just getting the data, various output currents, IB versus IC or VC versus IB, anything like you have got the information from your display, like and you are changing into curves. But here in application area, when you think about there the testing, you have you can see the curves, but the end product, that's your result here. So always get focused in a way bringing reality to your innovations or to your ideas, and that is the application, bringing reality of your creative things or your ideas, bringing reality to your ideas. That is the application. It is not restricted with water, public or street lighting, or location tracking, any of these lights. It's about making a system that should work for you. That is the application area. So here water and gas metering, and we don't have any physical contact with the electronics. I mean, I'm not saying in a wrong way. We don't. I mean, in this right now in this 2021 in this generation, we have very physical contact electronics, mostly with the non-contact electronics. It means the size and utility of cable is getting reduced. And very basic example. Earlier we have around 5 meter wire for charging our mobile phone, but wireless charger has come right now. Similarly, in water and gas utility meter is, for example, if I need to get the level of my water, either in the underground level or in the overhead tank, I should not. I need not to carry. I need not to carry the wire from 17th floor till the security office, because the security office, he will get the information how much water availability in each and every tank from the basement. When you through the electrical cable, you just consider how much like when you have huge apartments where you have around 200 to 300 flats. Just imagine how many water tanks needed, and how long you have to through it the cable. And those non-contact applications, water and water metering. So there is a concept called radio frequency data sensing. So there's a module called LoRa, LoRa, and this gives you the high range data transfer around 2 kilometers and around 8 kilometers apart. You can get even small RF will give you 10 meter. It depends upon the range of the sensor from 10 meters to 8 kilometers. You have LoRa modules, just of LoRa, and they are pioneer. I mean, from my point of view, of LoRa. Public security, street lighting, a smart street lighting. Everyone knows street lighting will give you the lighting, but a smart thing that you can add here is you can make it smart, like when someone yeah, and also like for example, when someone lights around the particular pole, it can change the brightness. That is the smart street lighting. Merely I mean, from off to on, it should not, you can't promise for the security during night level, during night time. The level of security level you can't imagine, but changing the brightness from low level to high level when someone interrupt there, when you have the movement there, so you can make the smarter way for street lighting system. And parking, you can have a huge malls, you have you can feel very difficult, like the security will ask you, better go this way, and you'll be moving from B1 to B10, basement 10. Just you will be there driving the car for around 10 minutes, and you will be missing the title of any cinemas and the intro of your favorite heroes, and it will take much more time, because again we have to reach from B10. We have to check the availability of lift occupancy. So even myself particularly have affected when I used to go for cinemas, like parking my vehicle around B6 or B5 and then going to third floor or fourth floor. So huge halls, you have a smart parking, and the entire parking unit will be controlled by a gateway where you can get the information where you have a slot, vacant slot, and location tracking. So GPS, you have known the application of GPS. You can see, and you are using it, tracking your destination using your app. So leak direction everywhere, right? So those things you would have know. Smart energy. I will tell you, environment monitoring or agriculture. You can in agriculture you can check the natural parameters, environment parameters, like the existence of we are getting information. No, this yeah, depression have formed, and it will be available last for next 5 days, and you will get a like in similarly in agriculture you can get a report like how many what is the level of humidity, whether I need to feed water right now, uh, the whether the fruits have been ripened, or when I have to cultivate. Those information you can get it from electronics. How? That's a common question. You have fruit ripen sensors, and you can check. There is a concept called mission vision. It is like I will just give you the concept. It will capture thousands of stills, and it will check with the reference. Though raw data, it is checked with the reference data. The reference nothing but your ripened fruit, and under sample is your fruit, and you can check it, and you can fix up the cultivation date. And because when it is ripened and you do the cultivation, it going to it going to finish. It will get disposed very in a short span of time. And when you get it very early also, it's not useful. So the right cultivation date, a lot of sensors in agriculture, right? In electronics and sensors, who is the real hero? Most of the question, real hero. Again, hero, real hero, not our actors. Maybe your father and your guardian who could be the real hero. But in electronics, the real hero is these four guys. Like these three guys actually. Sensor, as I said, and then who is going to transfer the information from sensor? This data transfer is can be could be done with the Wi-Fi shield or low frequency. From low frequency to even high frequency ranges also there. LoRa radio frequency modules, and platform is nothing but the data storage or any applications. For example, for example, you are very recently we are seeing some ad with the yeah, what is it, a ceiling fan. You can make it switch on and off, you can vary the speed. So in this example, you have the infrared sensor, you have the Bluetooth sensor. From here I'm giving the command from through Bluetooth network. You have the Wi-Fi shield sensor, and from my Wi-Fi I can give the information, a certain code. Say for A, it means when I send A, it will work with the 25% low speed level of ceiling fan. When I send B, it will rotate with the half of your speed level, B, C, D. How low? It's similar to low, medium, high. And in this project, between the mobile phone and fan, you have the Bluetooth receiver and Bluetooth module from your phone. So those are the sensors. Those are the sensors. Like actually, it's not a sensor. It's a platform of sending the information. The sensors is nothing but the smart way. And here, when you just imagine, you have a various module here. One is Bluetooth, and the other one is like sending the data. This Wi-Fi shield, these are actually on the network. Not these are the sensors. These are the networks. Like Bluetooth is the network, and radio frequency is a network, or Wi-Fi shield is a network. And I'm giving maybe yeah, ceiling fan. It automatically switches on depending upon the temperature here. It's not like switch on to 100% level. When I get minimum temperature, it should work with the low speed level. And even your mobile phone has a inbuilt, some of them has a temperature sensor integrated. And there are some applications, just we have to trigger it. But it is very available at uh, when you think in that way, then you have one more thing added needed to it. that is Google or with the Amazon Echoes or similarly, it will give the temperature and will send it to your PC, and from PC it through Bluetooth device you can switch on your. So this sensor maybe I can say even this way, we have a certain dedicated system where it will give the temperature when it is low, then it will send the data to your mobile phone, from mobile phone to your gateway to LoRa. So these are the real heroes here. And apps data, it's a storage device. You can get how much data, I mean how much EB consumed by your ceiling fan alone, not only ceiling fan and other devices. And I can make it to the graphs. That's nothing but your application. So your Android applications you can see here. We have spent more time in this slide. And where to start and how, it's a big question among you. uh, Again I'm telling, like, making a beautiful story is very very easier, but implementing is very difficult. So where to start and how? I think the next slide will give the information, right? Only the thing by you can start is learning by doing. So you have the data, you have a certain data document, data sheet data sheet where you can have, it's a PDF file. When you even every component has its data sheet. Name and data sheet, you will get a PDF, and in the PDF you can see the last pages, application schematic, how we are going to use the component. And when you say module, you will be having, when you get a when you get a module from online, you will be having option in the website resource, or under the product you can see the resource materials, where you can see schematic, sample code, a sample application. So this is a place where you can start with your electronics, learn by doing and experimenting it. That's what, in experimenting it already. Yeah, see, this is a basic slide. Like earlier we have discussed about the applications. The n number of n applications are there. Even one day is not sufficient to discuss with you about the application. My simple statement is, whatever the product, whatever the product you see, and whatever the thing you can recreate or modify it, it becomes application. Guys, I'm saying again, these 4 years should not go waste, because it's your passion, the purpose of education, the purpose of learning electronics. You have to get it in such a way, what I can do on my own, how I can recreate it, or how I can modify it, or how my work, it's you can get utilized by uh, how your work will be utilized in this society, how others you are going they are going to utilize your passion, your work, your enjoyment. Like the, this is electronics, creating your ideas into a product. That is the application area. That's a simple application area. Even you see a industry, you have lot of machineries, you have lot of sensors, you have like n number of if there is a big difference between the textbook and the practical industry. In the practical machinery, it's a simple, it could be a machine, but it is it works with the pneumatic, which is not an electronics. It works with the hydraulic. There won't be any electronic components, but a person who activates the particular, a person in the sense, I'm not asking saying about the human being, the module that activates the pneumatic or that activates the hydraulic, and that is the electronics, that is the application area. When it has to free the fixture, jig fixture, when it has to hold the fixture, when, so these are the thing, applications. And here power supply, the designing, and you have heard about 78XX, but you have just I said no. If you want to learn 78XX regulator, just surf in Google data sheet where it will give the information what is 78XX. So what are the various ICs that is manufactured along with the series 78XX. So those information I have took this from data sheet. What is the minimal voltage? What is the max? What is the rectified voltage? Regulated voltage? So 7805. So that's what I have said you, because when you say 7805, we will get information 78, it's a 5 volt regulator. But in datasheet it will give you, there is not any IC related with 7807 or 7810 or 7811 or 7813 or 14. They are not manufacturing these ICs. They have only written. So this information like this you can create your own, or you can explore yourself only with the user manuals. Again, just you can note it down: user manual or data sheet or specification, not with the end schematic, only with the scratch of your information, data information. So it's a variable regulator. Again here LM317, it's a variable regulator. And this basic this is from application schematic, a basic application schematic. This is how you have to connect yourself. And this output voltage, you have that proportion equation. It will give you this much voltage when you select the proper values of on R1 and R2. Because it's a voltage regulator, it's a variable voltage regulator, not the fixed voltage. Earlier what you have seen, it 7805 is a fixed voltage, LM317 is a variable voltage regulator, and the varied voltage depends upon R1 and R2. So this information you get from data sheet. And this is a basic timer actually using 555. You would have because earlier the story, the sensors, LoRa module or Bluetooth or Wi-Fi shield, you have not heard it earlier. But this 555 or this one previous, like 7805 or 783 LM317, these are the variable regulators. And industry they call as LDO, linear dependent oscillators. So fixed regulators. And some hope this is very known to you as stable. Actually the application of this schematic is like in digital photo frames, where you can see in digital photo frames, you can see a red series of red LEDs will glow. That time output 2 green LEDs will off. And again when output 2 green LEDs when get it switched on, the output 1 red LEDs will off. So those are like anti, they are not synchronized, they are complementary. When it's zero is output 1 is 0, that time it's 1 here. So you can do it by driving with a transistor, a series of LEDs, and you can make photo frame. So this is a simple application. At this stage you should experiment by yourself. You can have a photograph and you can decorate with the LEDs, and you can design the stable. You can feed it to LED, red LEDs, and other output feed it to green LEDs similarly. Right. And this is a light intensity sensor, like simple LDR. Here when you say smart lighting, it gets switched off automatically around 6 p.m. where you have very low sunlight. I mean, it will get switched on where we have very low sunlight. So this light intensity sensor, either it's a photoelectric sensor or LDR photo resistive sensor, the main concept is the variation of resistance with the light. So this is a basic schematic, and you have a new term relay. And just check what is relay, how it is physically. So this is how you can start. And the other circuits like here it's not like we can do just switch on and off your television with the remote. You can switch on and off with any appliances with remote, actually, not only with the television. Only thing is you should have a sensor and receiver. So infrared transmitter, You will be having infrared transmitter in your handy, and you will be having photo transistor TS0P, TSOP1738. So this is 1738 IC is a photo transistor, and it is respond to these infrared signals from transmitter, your receiver. Then CD4017, actually it's a counter IC. When you press it, it receives the signal and it will give the output. When you press again, it will receive the signal and it process the output. So depending upon the counting, it's a counter IC. The first pulse will latch it and then give the output. When you see here, there is some hidden things are there, like CD4017. There is a very important function, or it's a reset function, and you have the pin output stage by stage 2, 3, and 4. So 2, 3 are the consecutive pins. You will get the output like 0, 1, 0, 0. Similarly, 0, 1, 0, and finally 0, 0, 1. So you'll be getting adjacent ones. First 0, 1, 0, and 0, sorry, 1, 0, 0, and 0, 1, 1. Happen 0, 1, 0. The reset function will and again. So when I press first time, switch on 2. When I press second time, switch off 3, off. When I press third time, it will reset in the sense again switch on, off. So this uh, and this information I just gathered from CD4017 counter IC, from data sheet, from user manual, from application schematic. So the only thing you can learn electronics application, it's only with the PDF. And some other circuits, it's a passive infrared signal. Transmit. It will just check the availability of human beings, and not only the human beings, even with the animal, it will triggers your system. So it is used for theft control actually. So you can place your passive infrared sensor around near your entrance after the unauthorized level, like after around 10 p.m. Then you can use this system for your security systems. When someone enter, as I said, proximity sensors, they work with the changes in the electromagnetic field actually. So inductive proximity sensor. Similarly, passive infrared sensor, they works with the changes in the temperature. It will radiate the temperature and it will receive the temperature also. But when human enters, it it falls over the human body, and then it will give you it the variation in the temperature. That is the sensor we are using here. So you can switch on the LED light. So this is the signal amplifier, and only thing is disadvantages. This guy will be in the same state around 2 to 3 seconds, because the pyroelectric film, it will respond. It will be in the same state for a certain time delay. And another disadvantage is even it will trigger the animals also. This is some other circuits. So LM358 comparator IC, because these are things you would have studied recently. 358, it's a comparator, it's an operational amplifier IC. And the LM35 is a linear temperature IC. So for every 1 degree Celsius, it increases, I mean, 10 millivolt actually, right? For every 1 degree Celsius, it's a, the output voltage which is very linear. It will increase 10 millivolt, and then I can feed it to the LM358. It's a comparator. It will compare with the fixed DC voltage, and here 10 millivolt from, and then it will when the temperature is more, you'll be getting more voltage. That is compared with the fixed, and it will give the output. So that is triggered by a relay. It's a electromechanical relay. And you just surf in Google soft relays. Those are different. You can achieve with the thyristors. You can switch your device on and off using thyristor. You can change the variation of power, and this is electromechanical relay where mechanical parts are there. You can't get the timing, but soft relay they will responding is more higher. Just surf in Google soft relays. And some other circuit like solar panel. This is a simple circuit. How I can use my zener diode as a sensor for over voltage protection. When battery, the maximum voltage for a battery to get fully charged is around 6.3 to 6.4. Either it's a 6 volt, it's a 6.3 to 6.4. So when you reaches it's a 6.8 diode here. Like when it reaches 6.8 diode, 6.8 volt, it will bypass your voltage and it will stop charging your batteries. So this is the function of zener diode. The feel the output, and this is where you can start, and this is where your application areas. It's not restricted with the particular 12 volt solar panel battery from for this panel alone. You can get a panel and you can check it, and you can check the battery level. When it reaches the maximum, you can check the bypass of your network, and you can check the safe of your battery. You can do the safe of your battery. Again, here comes LM317, and you have R1 and R2, as I said, right? And in miscellaneous circuit other we have LED lighting system. It's an emergency lantern. Always please start from basic, guys. Don't directly go and touch with the integrated circuits when you start from first stage, because last 2 years uh, it's completely changed. It makes students, make the professionals. It has changed the natural human beha- behavior among uh, creating your own ideas. So this is the basic proximity sensor schematic where I can use for my smoke detector. So you have a transmitter. Actually, this is the thing. It's available in smoke detector. When you remove the smoke detector, you can verify it. You have a simple infrared sensor. Uh, you can like any. It is dependent of your smoke, snow, everywhere. In our industry, like one day when you are working, and suddenly we got a alarm sign from this guy, smoke detector. I mean, we just were running and we are assembling in the safe point. Later we come to know there is no any flame or any fire even in the flame sensor. This is a basic concept behind the flame sensor. One is doing the maintenance operation, and suddenly a part of dust enters into this, and it initiates the fire alarm. So you can you can fix up, or you can create your own fire alarm at your home, and you can start with this. So this is the application areas. And so this one PCB design, as we discussed earlier. Sir, Vignesh sir, can you hear me, Vijay Kumar sir?
Yes, sir.
Shall I give some 5 minutes break, or shall we continue with this?
Sir, it's time over, sir, already.
Okay. I think till I thought 1:30 uh, we have
Time,
scheduled,
but
right?
somebody having class at 1:30,
At
sir.
what time, sir?
1:30.
1:30. Yeah.
Oh,
Okay. Okay. Oh, I thought I can give the demonstration of Arcade software, sir, for PCB design.
okay, sir. Okay, sir.
I will finish up within 20 minutes, sir. Is that okay?
Okay,
Fine.
okay,
Fine.
okay, okay.
Fine. Fine. Uh, Actually, this particular That is the PCB. So we make the circuit in general purpose boards, but which is not rigid, which is not it has some complaints. Very often it gets open circuit. Very often it is not very fixed. So we are going for PCB. Then simple word, because we have very 20 minutes. And the mistake is with me. I'm again sorry. Like I have missed around 20 to 25 minutes earlier. Anyway, so, guys, sure we are going to meet some other day, because last 8 years we are serving for VIT University. To get benefited from us, utilized by us. You can utilize us, and we are here to help you. You can get it from me. You can test your adverse. You can come to office. You can create your own products. Sure. And this time restriction, it won't stop the interaction between yourself and others, and between myself and VIT. Sure. We have much more plan. We are discussing with Jake Master. Maybe when we have a personal interaction in your auditorium soon, I'm waiting for that, and we can discuss more. I can give you demonstrations of real life application. I have around 20-25 applications. So it is like about living with electronics. The name title is living with electronics. From 11 a.m. sorry, from 4 a.m. till night 10 a.m. How I can spend my time with the electronics. It's not like doing some work every day. It's about have feeling with the electronics every second. I will show you. Right. So the PCB design, the basic thing is the physical support between the electronic component is the PCB design. So need of PCB, as I said, the dot PCBs, general PCB, particular general PCBs, breadboard, they are not fixed. Like you will feel maximum open circuit. Need of PCB design, open circuit connections. The system looks compact. Yes, because when you see the laboratory digital electronics, when you do the experiment with digital electronics, you can see only the wires meshed together and not even the breadboards. You have only wires there. So this particular PCB design, you have a simple fiber where you have the electronic trace, I mean trace, copper trace over the fiber, and that forms the printed circuit board. And assembled PCB is nothing but your product. Assembled PCB is your product. A lot of softwares, Arcade, Multisim, Express, Eagle. Yeah, in Arcade there are two modules: Arcade Capture CIS, Layout Plus. I will share my ID just soon, and I will show you how to work with Capture CIS and how to work with Layout Plus. So I can upload a video for working with Capture CS. I had a plan to do right now, but we'll see. And this is a capture window where you have set of components assembled. So when you think about the PCB, printed circuit board, printed. You can't print, you can draw only with your hand. So we need the help of a PC, printed circuit. First we need to draw the schematic, and then we have to convert into layout, because in PCB, in your mobile phone or in your remote controller, you have a track running around the PCBs and no more circuits. You have the tracks. Just check the do one thing. Just go and take your remote controller, unscrew it, and see the PCB. You have lines around the PCB. Don't forget the screws here. So these tracks, that is the purpose of your computer. That's the purpose of your arcade software. Earlier, first you have to draw the schematic, and then you have to convert into a layout like this. So these red color line you are seeing, these are the tracks and these are the components. These are the components, and this thing, these are the places where we do the drilling. There are two types of technology in PCB design and PCB assembly. One is through hole technology. Through the hole, we are placing the component and doing the soldering in the bottom portion. And another one is the surface mount technology, where you do the assembly process over the surface. And this is another simple schematic related with the IC. Actually, this looks like a game. This looks like a game. These are not a short circuit, but this junction. Only thing is, I should not get dot here. When I get a dot here, it means a short circuit. We have to drawing is very simple, but conversion of schematic into your PCB is very important task. So here, this is the basic PCB layout. This is the process of PCB. Choose your design software. I mean, finally your schematic, working schematic, sir, not with the under test schematic, working schematic. Uh, you can break up the big projects into four PCBs. You can check each and every module. I mean, you can break up into module. You can check each and every module, right? Capturing a schematic and designing component footprint. Footprint is very important name. Like in layout, we have 3-pin ICs. We have 4-pin. I mean, 8-pin discrete ICs. You have pins on both the sides. You have pins on only single side, that is SIP, single inline package, dual inline package. What you touch LM358, LM, I mean 555. Those are the dual inline package ICs. Some of the ICs like LM317 or LM7805 regulator ICs do have only one side pins. Those are the single inline packages. Routing process is very important. So there are a certain design rule check where because not you are going to print it, you are feeding into a machine, and the machine should understand whatever the schematic you route it here, it won't give the output. A proper design rule should be there. We have to check it before feeding into a machine. So the machine, file we feeding into a machine, that's called Gerber file. And manual masking process, etching process, drilling process. It's a manual operation. We do some workshops in institutions, like how PCB can be done without the help of the machines by students. How you can make on your own only with the resources that is available in college. So if you don't have any PCB design machine, you can make on your own. And I'm going to show you a video finally, like how you can do with your manual process. So these are the coins you are going to learn in PCB, I mean workshop. Not about workshop I'm going to speak right now. Just I'm sharing my information. It's a masking process, etching process, assembly. Like this is the extension file. Maybe when we work, we will get understand it. Start with simple. Don't go for any 16-bit IC or 64-bit IC. Start with a simple passive component. Create it, recreate it, modify it, and make your own applications. Finally, a video I have. So there's arcade software. We have to design it and we have to convert into a layout. So it's a photo sheet actually. It is available in nearby stationery shops. We have to get the laser printout of your routed PCB, routed schematic. So this is plain copper clad board. This is available from us also. Right. Uh, Clean it because the moisture over there, when you do the ironing process, it will create some air gap and it will the particular design won't stick with the copper clad board. Clean it. Firmly press paper to the board with the preheated iron. So at the edges, you should focus because when you do any gap, when you find out any air gap between this paper and the PCB, it won't stick. So be careful. Not hot water is required. Normal water is enough. Just peel off the paper, and you should not do with your nails. It will remove your tracks. This is the very important place of this video. You have the paper, unwanted paper here. So you have to remove this one, or else when we put this in the etching solution, the extra copper will go away, and the copper just behind this paper, it won't. It will be available, and it will make short circuit. It's a very important place here. This process is called etching process, and the etching process will be more faster when it is exposed to the sunlight. than the room temperature. This hot water is not required, only etching solution is enough. Precautions you should take is you should not inhale the excess gas. And this extra copper will get has removed because the ferric chloride will dissolve the copper into granules that get deposited in ferric chloride solution, and only the trace that is left is nothing but your printed carbon from your laser printer. So this mask your track. This mask the copper layer under this track, under these traces, and that's your printed circuit. So just acetone, you can clean your PCBs. This dust will this is used by most of you as a nail polish remover. So we have drill machines, manual as well as electrical machines, PCB drill machines. This is a thing, yeah. The thing you are seeing here, there is a through hole technology. For example, you are placing the LEDs in the top side and you are doing the soldering process here. So in the top side, it is the bottom side, and in the top side, you have the component. In the bottom side, you have the component legs that has placed through the hole. It's a through hole technology. This is called surface mount technology. So you don't have the contact between top side and bottom side. Only you are placing the component at the bottom side. This is a surface mount technology. Those are the resistors. There are packages for surface mount technology. 040307 series, like it is the size of the component, length as well as width. It's not like that. Right, sir. Guys, this is my mail ID. This is my contact number. You can just send a mail to me for any information, and I can share the presentations to Vijay Kumar sir and Vignesh sir. So thank you very much, guys.
Okay,
And
sir.
I'm eagerly waiting for you guys to see in our institution. Thank you, guys.